Or Alhamdulillah. So up to last class, we have finished optical instrument. I left a homework question for you. Advantages of reflecting type telescope or refracting type. Did you get those questions? Those points?
Yes, sir.
Yes, sir.
Okay, sir. For reflecting type telescope, that's very, very important. Next. Okay, after optical instruments, the next topic is prism. So at least for the initial discussion, we can use this slide. So prism is a three-dimensional figure basically. This wedge-shaped figure is your prism. Triangular wedge. The top view is triangular, then you have a rectangular face, two rectangular face inclined to each other. This is the prism. But when we use prism in the ray diagram, we just draw the top view of the prism, which is this. This is the top view of the prism. This angle, this particular angle is known as the angle of prism. This A is the angle of prism. So what is prism? Prism is just a wedge-shaped portion of a transparent refracting medium bounded by two plane faces inclined to each other at a certain angle. So these are the two faces, this one face and this another face. So there is some few names of each face. This face is known as refracting face. This is the edge, refracting edge. And the most important thing in prism is the angle of prism. No one will give you these type of this whole three-dimensional prism. Whenever you have prism in question or in theoretical, in a numerical or in theoretical question, you have this type of prism. So the angle between the two faces is known as angle of prism. So in prism, the major part of your calculation is to get the deviation produced by the prism. Just note it down, then we will start with the deviation. Okay, at least for the ray diagram, I will use this diagram. For calculation part, I will do the calculation. See. So is it, have you written this definition?
Yes, sir.
Yes.
So see, in prism, what we have to calculate, we have to calculate the deviation produced by the prism. So this is your triangular prism. This A is the angle of the prism. So this is the first face. This is the normal on the first face. Let's name this normal as N. So your light is entering in the prism. If it does not refract, then it will go straight without any deflection. But light is moving from air to glass. So what will be the direction of refraction? It will refract towards the medium or away from the medium?
Towards the normal.
Towards the normal.
Towards the normal. So this is the normal. This is the incident ray. Now, since ray is moving from air to glass, so it will bend towards the normal. This was the incident ray. This is the refracted ray. This is the refracted ray. It will bend towards the normal. So this is the angle of incidence. This one is the angle of refraction. Let's rub these angles, at least for the time being. Let's rub these angles. We don't need these angles. Don't need these angles. So for the first surface, this is the angle of incidence and this is the angle of refraction. This is the second surface. So ray is moving from glass to air. If there is no refraction, then this ray will go straight. But since it's moving from glass to air, it will bend away from the normal. So when it bends away from the normal, this E is the angle of emergence. So for this face, this is the angle of incidence. We name it R2. Just because one angle inside the prism is R1, so we'll call this angle also as R2. And this is the angle of emergency. And see, this is the incident ray. This is the emergent ray, the angle between the incident and the emergent ray. This is the emergent ray, this is the incident ray. This angle is known as angle of deviation. Angle between incident and emergent ray that we are supposed to calculate. We have to calculate this angle of deviation. So the major part in the calculation of prism is this deviation. Draw this ray diagram, then we'll start the numerical mathematical calculations. Just tell me once you have drawn this ray diagram.
Done, sir.
Malia, Mariam,
Sir.
Shazada,
Yes.
noted?
Yes, sir.
Yes.
Now let's start the calculation first. Rub it off. So you just have to calculate. There are two calculations in it. One is the calculation of angle of deviation, and another is the relation between the angle of prism and the angle of refraction. So let's take this triangle first. In triangle ACNM, let's call this point as M. This is N and this is N. I need this angle, this one, and I will need this angle. Mariam, how much is this particular angle? This whole is I, this is R1. How much is this? Mariam, at least try. No. Nazira, how much is this angle? This angle. Shazada, this is I, this is R1. How much is this? This one?
60 degree.
No. See, this angle and this angle, this whole, they are vertically opposite. So if
Yes,
this
sir.
is I, then this is also I.
Yes,
And
sir.
Shazada, this one is R1, this much is R1. Then how much is this?
This is also R1.
No, this whole is I. This is R1. Then this leftover angle would be just,
1/2 I.
no, it will be I minus R1. See, this whole is I. This angle is I. Okay. So I'm drawing it here also. This whole angle is I. From this I, this much is R1. Then this leftover angle will be, yes, Shazada. How much this angle?
I minus R1.
I minus R1. So this will be this particular angle will be I minus R. And what about this angle? This total is E and this is R2. Shahzada, how much is this one?
Say E minus R2.
E minus R. So if we take this triangle C and M, in triangle C and M, this and this are interior angles, this is exterior angle. These two are interior angle, this is external. So you can say this plus this is equal to this. You can say that I minus R1 plus E minus R2 is equal to the angle of deviation. So you have I plus E minus of R1 plus R2 is equal to the angle of deviation. This is my first equation. So you got angle of deviation in terms of angle of incidence, emergence, R1 and R2. Now let's try to connect these two angles also, A and R1, R2. So see, if I take triangle NM, let's name this as something else. This is NM, let's call it as P. In triangle NMP, 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 R1 plus R2 plus angle P, R1 plus R2 plus angle P is equal to 180 degree. That's my second equation. And in quadrilateral ANPM, in quadrilateral ANPM, see the sum of, how much is the sum of opposite angles of a quadrilateral, Nazira? Nazira, how much is the sum of opposite angles of a quadrilateral? Good, Noor. No, Nazira, not 360, it's 180. 360 is the sum of all four angles. Huh? The sum of two opposite angles is 180. So the opposite angles are A and P. So you can say that A plus angle P is equal to 180 degree. That is equation number 3 now. Now you can equate them. If you want, you can equate equation number 2 and equation number 3. So just equate 2 and 3. So when you equate them, you get R1 plus R2 plus angle P is A plus angle P. So this angle P will cancel this angle P. And you are left with R1 plus R2 is equal to A. That's equation number 4. So you have this thing, delta, which is I plus E minus of R1 plus R2, and you have A, which is R1 plus R2. So this is, let's substitute 4 in 1. This is the angle of deviation, which is I plus E minus A. This is deviation. This is equation number 5 now. Note it down. Then we will connect it with the refractive index also. We'll use Snell's law and we'll try to connect it with the refractive index also. Abdullah, by the end of this month, Feb, you have exams in April, no?
No idea, sir.
Exams in India, it's in April.
Board exams?
Yeah.
But they didn't release the date sheet, right?
They didn't release the date sheet, but they gave an idea like it's around some April.
Okay.
We can complete it up to third week of Feb also, because that modern physics and this semiconductors are one class topics.
Okay.
Written up to here?
Yes, sir.
Next is we can write this angle of deviation in terms of refractive index also. We can write in terms of refractive index also. See, if I apply Snell's law at n, see this is air, the refractive index of air is 1. This is glass, its refractive index is n. So if I apply Snell's law at n, so when you apply Snell's law at n, this is I. So you can write 1 into sine I, which is equal to refractive index is n and angle of refraction is R1. So you can say that this is n into sine R1. So we have sine I is equal to n times sine R1. If I apply small angle approximation, then I can write that I is equal to nR1. That's my equation number 6. Similarly, if I apply Snell's law over this point, M, similarly, yes, no, refractive index of air is 1. Similarly, we can write that your E is nR2. That is equation number 7. Now what we can do is we can substitute this 6 and 7 and 5. So when we do this substitution, like when we substitute 6 and 7 and 5, we get delta is I plus E, which is nR1 plus nR2 minus A. So delta is n is common. We have R1 plus R2 minus A. So R1 plus R2 is A. This is equation number 8. We can substitute this 4 in it. So when you substitute 4 in it, we get delta is n, R1 plus R2 is A minus A. So we'll get delta is A into n minus 1. So this is again a relation for deviation, but we will use this relation only if small angle approximation is valid. So we use this relation for small deviation. We use this relation only if deviation is small. Otherwise, you can't use this relation, because while using this relation, you are using the fact that I is NR1 and E is NR2. So this relation is valid only for a small deviation. So we have three relations for deviation. One is this, that deviation is I plus E minus R1 plus R2. Another is this, that deviation is I plus E minus A. And the last one is this, that deviation is A into N minus 1. These are the three relations for deviation. No, written. We have already written it. Yes, Nazira, clear or any doubt in it? Raj, it's not your badge. Please contact Nishkash for the correct meeting ID. Written?
Yes, sir.
Okay. The next is the case of minimum deviation. Let's call this as equation number 9. Now let's take minimum deviation. And Prism formula. Minimum deviation and Prism formula. See, what is minimum deviation? So if I plot deviation versus angle of incidence graph, on y-axis I'm taking deviation, and on x-axis I take angle of incidence, it's deviation. So this is the graph. So for a particular deviation, we have two values of angle of incidence. One is angle of incidence. Another is the angle of emergence. And see, for this particular value, the deviation is minimum. So when the deviation is minimum, both the angles are equal. Angle of incidence is equal to angle of emergence. So when the deviation is minimum, then I and E both are equal. So this is what we call minimum deviation. for minimum deviation, I is equal to E. That's first condition. So if this is for equation number 9, I'll just continue the equation number. I call this as equation number 10. See, the consequences of this I and E equality. If I is equal to E, that will imply that R1 is equal to R2. That is equation number 11. If I and E are equal, that means R1 and R2 are also equal. Now, if they are also equal, just put these values here in equation number 1 and you will get an equation for delta. So I'm substituting 10 and 11 in equation number 1. So these two conditions are valid only if you have the case of minimum deviation. Otherwise, you can't use these two conditions. This is valid only for minimum deviation. So when you substitute it here, you get delta minimum is I plus E it was. So you can write I in place of E. R1 plus R2, so you can write R1 plus R1. So you will get that your delta minimum is it's 2I minus 2R1. That is equation number 11. That's one equation. Next, what we can do is for minimum deviation, see this one. R1 plus R2 was equal to A here. So if I put R1 equal to R2, then you will get R in terms of A. So I'm substituting that R1 equal to R2 in 4. So when I substitute this 11 in 4, that means I have A is equal to R1 plus R1. A is equal to 2R1. So you get R1 equal to A by 2 now. That's equation number 12. Next was this equation. Delta is I plus E minus A, 5 equation. Now what we can do is we can substitute this 10 in 5. So we get delta minimum is I plus I minus A. So I get delta minimum is 2I minus A. Or you can say that 2I is its delta minimum plus A. Or you can say that your I is its delta minimum plus A divided by 2 now. Let's call this as equation number 13. So you have R1 and you have I. Then there is one formula which is known as Prism formula. Prism formula is nothing but the Snell's law. Prism formula is refractive index of the medium of prism is sin I by sin R. This is it. That's 14. This N is refractive index of prism with respect to surrounding. With respect to surrounding. When you substitute all values here, if you substitute 12 and 13 in 14, it's sin I, which is delta minimum plus A by 2, divided by sin R, or it's R1. R1 is A by 2. This is the relation that we call Prism formula. So the only derivation that can come from the prism is this Prism formula. The sin A plus delta minimum by 2 by sin A by 2. Note it down. So for minimum deviation, remember these two conditions only. I is equal to E, R1 equal to R2. That's it. No need to remember all these relations. You can get all these relations from the equations, these equations, 4, 5 and all. But you should remember this, that minimum deviation means angle of incidence and angle of emergence are equal. Angle of refraction for first surface and angle of refraction for second surface are also equal. Note it down. Yes, Noor. Prism formula can also be derived for the minimum deviation. Tell me once you have written.
Done, sir.
Okay. Written?
Yes, sir.
Noor, we write this Prism formula in terms of minimum deviation because the minimum deviation is fixed for a particular type of prism. Angle of incidence can vary, angle of refraction can vary, but this angle of prism and the angle of minimum deviation is fixed for a particular type of prism. They're like signature.
Okay, sir.
That's why we write this formula in terms of some parameters which does not change. Angle of incidence will change, angle of refraction will change, angle of emergence can change. But this minimum deviation and angle of prism are fixed for a particular prism. That's why we don't. That's why we use minimum deviation while deriving this formula. Written?
Yes, sir.
Okay, let's do few numericals. Does everyone have written? Amalia, Mariam.
Yes, sir.
So let's do the first question, formula based. Calculate refractive index of material of an equilateral prism for which angle of minimum deviation is 60 degree. So see, we have angle of minimum deviation, delta minimum, which is 60 degree. Is an equilateral prism, means all angles are 60 degree, A is 60 degree. So see, it's a one line calculation. Delta minimum, you know, A, you know, just put these values and get the value of it. Do these calculations and write your answer in chat. Good, Abdullah. What about others? Answers? Amalia, Noor. The one line calculation. Good, Amalia. Right, Noor. Mariam, Nazira, you two are left. Answers. Just put the value of delta minimum and A and here. Sine of A means 60 plus 60 divided by 2 divided by sine of A by 2, which is sine 60 by 2. So you have N is sine 120 by 2, which is sine 60 divided by sine 30. Mariam, Nazira, answers. Sine 60 is say root 3 by 2. Sine 30 is half. You can cancel them and N is root 3. So the refractive index of the medium of prism is root 3. Note it down. Nazira and Mariam, is it clear now?
Yes, sir. Next thing. A ray of light passes through
an equilateral prism such that angle of incidence is equal to angle of emergence. Or is it any special condition when I and E are equal? Is this any special condition when angle of incidence and angle of emergence are equal?
Yes, sir.
Which condition is it?
Sir, it is minimum deviation.
Yeah, this is the condition of minimum. 3/4 times the angle of prism. Calculate. First, the angle of deviation. Refractive index of glass prism. See for the do it and write your answer in chat. Equilateral prism means A 60 degree. Mariam and Nazira, I have to see your answers in chat room. This is easy problem. Okay, Noor. Yes, first is correct. Yes, Noor, first part is correct. See, it's an equilateral prism. Put A equal to 60 degree. Angle of emergence is given is 3.3/4 times the angle of prism. So it's 3/4 into 60 degree. It's given that I and E are equal, so I is also 3/4 into 60 degree. No one line calculation now, angle of deviation, and then refractive index. You can use Snell's law. Good, Amalia. Good, Noor. Refractive index is also good. Abdullah, your answers?
Yes, sir.
Nazira, Mariam, you're not solving, huh? Okay, Nazira, I'm helping you. Nazira, just tell me, how much is the angle of prism? Yes, Mariam, it's correct. Good. Nazira, what's the value of angle of prism? Okay, she's not in class. Angle of prism is 60 degrees. Angle of emergence is 3 by 4 times the angle of prism. 3 by 4 into 60, so it's 45 degrees, which is equal to angle of emergence. See, how much is deviation? Del deviation is this, not this one. I plus E minus A, that's deviation. Good, Abdullah. It's I plus E minus A, that's deviation. So how much is I? 45 degree. How much is E? 45 degree minus A, which is 60 degree. So your deviation is 30 degree. Next, you need refractive index. Refractive index is sine of A plus delta minimum divided by 2, divided by sine A by 2. No. You should consider this sign in Prism formula. Unless it is given that A and delta minimum are very, very small. Unless it is given that these two angles are very small, you should always use small angle approximation. Always.
Okay, sir.
Sine of A plus delta minimum by 2 divided by sine of A by 2. So you have sine angle of prism is 60, delta minimum is 30 divided by 2. Divided by sine of A by 2, A is 60 divided by 2. So we have N is sine 45 divided by sine 30. Sine 45 is 1 by root 2. Sine 30 is 1 by 2. You can take this 2 in the numerator. It's 2 by root 2. It's root 2. So the refractive index is root 2, which is 1.4. That's the refractive index of the medium of prism, 1.4 or root 2. Do it. Tell me once you have written.
Done, sir.
One last question. One last numerical. Last type of numerical. Array of light PQ is incident at an angle of 60 degree on the face AB of a prism of angle 30 degree. As shown. See, this is the angle of incidence. This is the angle of prism. The ray emerging out of the prism makes an angle of 30 degrees with the incident ray. Show that emergent ray is perpendicular to the face BC through which it emerged. Also calculate refractive index of prism material. So this is the given figure. So this is the prism. This is the angle of prism, 30 degree. You incident this ray. This is normal. This angle is given as 60 degree. This ray will refract. He's asking, get the condition when this refracted ray, this emergent ray is perpendicular to this. It's perpendicular to the face of the prism. You have to prove that this ray, emergent ray, is perpendicular to the face of the prism. This is A, sorry, this is B, and this is C. Face BC, not face BC. Okay, face BC is given. So this angle is given as A, and this angle is given as B. Okay. So everyone have written.
Yes, sir.
You have to prove that this ray is perpendicular. If this ray is perpendicular to the face BC, Amalia, can you tell how much is this angle of emergence? If the emergent ray is perpendicular to the face, how much is the angle of emergence?
180 degree.
90 degree. Okay. Mariam, what do you think? What should be the value of angle of emergence here? If it is perpendicular to this face?
90 degree.
90 degree. Abdullah?
Uh, 90 degree.
Uh, we measure angle with respect to the surface or with respect to the normal?
With respect
0
to
degree.
normal, 0 degree.
Yes, Noor is correct. 0 degree. See, this is the normal. Now we measure angle with respect to normal. See, here also we are measuring angle with respect to normal, not with respect to the surface. So if the ray is passing normally, it's making a 0 degree angle with the normal. Your angle of emergence is 0. I'm repeating again, we measure angle with the normal, not with the surface. So if the ray is perpendicular, that means it's perpendicular to the surface also. Angle of emergence would be 0 degree. E0. So now you have your E equal to 0. So your I is, I'm writing it again. I is 60 degree. Angle of prism is 30 degree. Angle of deviation is given. How much is deviation? Deviation is 30 degree.
30 degree.
I need angle of emergence. If you have to prove that this ray is perpendicular to the surface, that means you have to prove that E is equal to 0. So we have a relation between delta is I plus E minus A. From this, sorry, minus A. From this relation, we can get the value of E. From here, we can calculate E. Let's put all values. Delta is 30. I is 60. E is unknown. Minus 30 degree. So see, if you take this 30 to the left hand side, you have 60 is equal to 60 plus E. E is 60 minus 60. But E will be 0. Angle of emergence is 0. Angle of emergence is 0. That means the ray is perpendicular. This is what you were supposed to prove in the first part. The second part is asking about the refractive index. For refractive index, you need just sin I and sin R. Sin R. I, we know 60 degree. We need R1. For R1, we can use this relation that R1 plus R2 is equal to A. Can anyone tell me how much is R2 here? See, this is R2, na? This. This angle is R2. How much is R2 here? If ray is going normally.
90 degree.
90 degree.
Again, from where we measure R2, with the surface or with the normal?
That would be normal.
If it is perpendicular to the surface, that means with the normal.
It's 0.
0 degree.
See, ray is going normally, na? So that means your R2 is 0, its E is 0, it's going straight. So R2 is 0. So when you put the values, R2 is 0. R2 is 0. And angle of prism is 30 degrees. So you get that your R1 is 30 degrees. So now you have all values. You have I and you have R1. Just put these values here. Sine 60 over sine 30. Sine 60 is root 3 by 2. Sine 30 is half. It gets cancelled out. So the refractive index is 3. This is the refractive index of the medium of prism, which is root 3. Do it. Okay. So that was about Prism. Have you done dispersion in your school?
No, I don't think so.
Dispersion, only deviation through a prism was in syllabus, not dispersion.
Yes.
Okay, so this is over. The next is wave optics. Ray optics is over. The next section is wave optics. Okay, are you free at some time on Friday, like around this time, around 8:30?
Yes, sir.
Yes, sir.
Most of the students are absent. I don't want to start wave optics today. Like if they miss the first class of wave optics, then entire topic get missed. So the next class we have on Thursday. After Thursday, we'll put an extra class on Friday. So the target is a very small topic, wave optics, just Heinz principle and this interference and diffraction. All other portions are being deleted. So at the end of this week, like by this Friday, we'll try to finish this wave optics. Huh? So I will leave here only. In the next class, Thursday, we will start wave optics, and Friday we'll try to finish it.
Okay,
Okay.
sir.
Okay, so let's stop here.
Thank you, sir.
Love this.
Thank you, sir.